Hi everyone, I'm back. Yes, I'll be doing more content on the following week, but I will start off with all the critical content. As some of you have witnessed that I've done the PBO limits, the curve optimizer and the curve shaper on a 9950X3D with a SRock X870E Nova motherboard. And you guys have been commenting, hey Cleo, please be more practical. Can you show us how to do the configuration on a 9800X3D, which I will be showing you with the boards that I have, like the MSI, the ASU, and the SRock. And for this, I'd like to thank AMD Singapore, okay, to have provided me with this sample unit. In fact, this is a hand-picked unit for me to do the tuning and such, to show you all the settings that is done on MSI board, ASU board, and on SRock board. For today, I'll start off with the MSI board. And not only that, I will also point out some of the critical things that you need to take note when you're doing PBO2 and the curve optimizer and curve shaper, as out there I have witnessed quite a few having processor dead, motherboard dead, and such. So with this say, right, I will like to highlight also another 2 points whereby why I emphasize that for RAM kit, right, do not go anything above 6400 bus speed, which right now with me, thanks again to King Bang to have provided 2 set. In fact, okay, this is maybe advertising, but I'm just saying that, see, I have tons of King Bang RAMs over here. Reason being, right, whatever King Bang RAM, be it the capacity or the speed or the bus speed, right, whichever board I plug into, right, I can just plug and play, run the Expo profile, and that's it. Anyway, back to where I was. As I'm mentioning that some of you have done, just follow blindly, so sorry to say this, follow blindly on internet and having YouTubers to tell you that, oh, do this configuration, do that configuration, especially on PBO limits with the auto configuration and the motherboard configuration. I would avoid these two. Instead, you will want to have full control of what you have planned to run your processor, as in the PPT setting, the amperage setting, and such, which I'll show you later. And at the meantime, explaining to you what are the things to take note when you're running high capacity RAM. Now, with me, I have 2 sets. Both are 48 GB kit, but with different timing. So this is the 2024 kit, and at a bus speed of 6000, and with a tighter timing, which is CL28, and this same capacity but of a different speed, which is 6800 bus speed, and of a looser timing, which is CL32. Now with this say, right, besides setting the PBO limits on your processor, right, you also need to take note when you're running RAMs, especially on high capacity RAMs, because there is a chip on the RAMs itself, is called IMC, where it will communicate to your processor. And on your VRM, right, there's this SoC socket, which the power pace is, okay, for this I think is, I can't remember the power pace of this, probably is 12 plus 2 plus 1, where the 2, right, is meant for the SoC on your RAMs. And some of you might not notice that having a higher bus speed, right, you can create more problems than to resolve problems. That's the reason why I emphasize that always go with the sweet spot. Do not damage the processor, do not damage your board by running off RAM kits which is 6000 or 6400 max. What you need to take care of is the tighter timing. That will help the performance. Alright, again with this said, let's begin just to show you the configuration on the 9800X3D with a 48 GB RAM kit that's running on 6000. Let's begin with installing Windows right after you have pieced up your system together in a case. But before you install Windows, first thing you will need to do is to update the BIOS to the latest, so that you not miss out on the performance and such, or any issues. So on this MSI B850M motherboard, I'll go to the website and to check on the BIOS and to download this. Now, do take note, if the BIOS is beta version, kindly do not download and to install. Make sure that it's actually a full version. So this is actually tested and certified. Once you have downloaded this and installed the BIOS, right? Now, for the step on how to flash the BIOS and such, kindly refer to the instruction manual. I'll not go through in this process. Once you've done that, right, the first thing you need to do is to give cooling solution to your system. This is the most important part. So I'll just click to hardware monitor. Then I'll set accordingly to whatever header that you plug your fans to. Take for example, this is an open bench. I only have the radiator fan and my pump. Okay, if you are in the case, right, you might have front fan, bottom fans, rear fan and such. You can select this and to configure. And to configure this is quite simple. Select the header that you want to configure. Take for example, the CPU fan is my radiator fans. So this is actually the graph that I will plot. So you can use this point accordingly. There are 4 points. Or you can make use of the fuse over here, which I prefer to use this. So having said this, right, as you can see, when I toggle this, right, see this will move. So I have total control on what I'm doing right now. Once this is done, then next thing what you can do is to enable the Expo profile on your RAMs or the XMP profile. Okay, depending on what kind of RAM profile that your RAMs have. So I'll just go to overclocking. Now for overclocking, right, the above I will not touch anything at all. Okay, I find that it's redundant, but if you want to be more challenging, right, you can do it yourself. But for the very first time when you are going to install Windows, right, just enable your RAM profile. So over here, I'll just enable the Expo profile, which is listed over here. Okay, and I know that my RAMs are running on 6000 bus speed, which is actually a 1-to-1 ratio. I can set the RAM speed to 6000. Now by setting all this, right, in fact, it will speed up the boot time and you will bypass the system from verifying what kind of RAMs it is. So you're telling the system that, hey, I'm using a 6000 bus speed RAM. Okay, you don't have to verify. Then as for the F clock, frequency clock, I will set it to 2000. As this, I can do a 1-to-1 ratio. Alright. Now, don't assume that you can follow my configuration over here. I know that 6000 bus speed is F clock. For the frequency clock, right, is 2000. So it depends on what kind of RAM you're using. If you're using 6400, right, please do not use this configuration, right? You have to find out yourself what are the F clock, what are the RAM speed and such. Now for U clock, as I mentioned to you, I can run this RAM on 1-to-1 ratio, very sure. So I just set this to U clock equal memory clock. Next thing I like to do is in fact the high efficiency mode. Now not all RAMs can run this mode. It just happened that my RAMs are on very tight timing and it's stable to run at this mode. So with this say, right, I'll just select high efficiency mode to enable and to set the memory timing preset to tightest. Now besides this, right, I will set offset on my CPU voltage, the VCore. I often like to do this, so I just do offset and I'll set it to negative. Okay, this will not harm the processor. In fact, it will, let the processor run at a cooler temperature and to only receive whatever voltage that is needed to push to that frequency. Okay, you can do that. Now this across the whole line, right, or should I say the whole MSI board, right, you can set any kinds of processor to run at offset of 0.05 volt. Okay, it will not hurt. And for this, now this is very touchy, whereby I will explain to you why I've set this, always set this to. And I know that the best method to have this SoC voltage, right, which is actually got to do with the connection of your RAMs, which is the IMC, to communicate with your processor, the PMIC. Now this two will need voltages and it's best recommended not to run above 1.2 volt. So most of the time I will just set it as a standard, be it a 32 gig kit or a 48 gig kit or even a 64 gig kit, right? I will set it to this voltage, which I'll set, okay, In fact, it's auto. By auto, it's quite dangerous. If you were to have a high bus speed RAM, which I'm going to show you later, or having a high capacity RAMs, right, it will pull a lot of wattages. So in order to stop that, right, and not to hurt your processor, I will do this. I know that for 32 gig kit, 48 gig kit, and some 64 gig kit, I'm able to run with the override wattage of 1.15. Okay, not 1.5, right? You're gonna kill your board. It's 1.515. The max is 1.2. Okay, if you're comfortable with 1.2, you can leave it. But for me, I'll just leave it 1.5. Once you have this, right, you can save the profile and to install Windows. And right now, I'm going to show you what after next when you install Windows. Assuming that Windows have been installed and right now it's on the Windows interface, first thing to do not hurry up to configure whatever stuff and to install stuff. Best way to do it is to make sure that all the devices are working properly. Just go to your device manager, check all the devices over here, make sure there are no exclamation mark. In fact, first time when you install Windows, right, you will get a prompt when you first boot it up, as this MSI board, right, have that capability to prompt you to install the drivers. So if you miss that, right, do not worry. And if you have exclamation mark over here, just go to the MSI support page of this motherboard to download the drivers. See, there are drivers over here. Make sure you install all the drivers, okay, necessary drivers I should say, and make sure these are all without exclamation mark. This is good to go. Next thing to do is to feed the board with the correct AMD chipset to work with your processor, and this you will need to download from the AMD driver and support page. By the way, all this that I mentioned, right, the URL will be in my description. You can just follow. So download this, okay, the auto detect and install driver updates for your onboard processor, graphics, and the chipset. So once you download this, right, you will have this application. Okay, it will load. Now, once you have done this, right, click on this manage update. Make sure that these two applications that is listed over here, one is the chipset, the other one is the AMD Adrenaline Edition. Make sure these two are updated. Once it's done, okay, good to go. You can close this. You will probably ask you to reboot and such. Just follow the instruction. The final step, okay, check on the Windows update. Make sure that there are no further update is needed, because there are some security patches and such. Once it's done, right, download all this application. Okay, I'll just leave this running. What are the application that I will do to do my tweaks? Now this is done. This is done. I will download Ryzen Master. Okay, this is the application. I will download Firmark. I will download Hardware Info and Aida 64. Again, all this URL will be in my description. First of all, to check whether everything is running properly and to take down the stats, you will first need to know how your processor works. Okay, I will just key over here, which is actually the 9800X3D. It's best that you write down your processor specs, okay, so that when you do the talk, right, and tweaks on the PBO limits and the curve optimizer and the curve shaper, right, you know exactly what is going on. So just go to this website on the 9800X3D processor and to click on the general specification. And from here, right, kindly, okay, let me just do this. Write down the necessary. As what's necessary, I'll just show you. So this is actually the default specs of 9800X3D. First thing you need to take note is what's the base clock. So base clock is at 4.7 gig. Okay, boost clock is at 5.2 gig. It's written over here. Now for the boost clock, right, is random push. Okay, at a certain time, right, it will just push to 5.2, but at all times you run at 4.7. Now the most critical part of the whole operation before you do the tweak is to make sure that what is the voltage. or wattage. So default recommended voltage is 120 watt, okay, which is known as the TDP. So take down on this. Once you've done this, right, as mentioned to you, install Ryzen Master, firmware, hardware info, and Aida 64. First thing, load Ryzen Master. Now, Ryzen Master will tell you all the default settings, because you have not done any settings, you see, as in like your PBO limits, your curve optimizer and such. So when you first time load this, right, without any configuration, right, it will tell you the default PBT, TDC, and EDC. Take this down. Okay. So later when you do the adjustment, right, it will be easier. You can take this as a reference. So I know that PBT is 162 watt, then the TDC is at 120 ampere, and the EDC is at 180 ampere. So having this, right, okay, let me just break this. Now, next thing to do is you can do a dry run without any configuration. See how much wattage the CPU power is pulling and such. Now, the most important part of the whole stats over here, right, is the CPU power. Make sure that this doesn't go beyond 120 watt TDP. That is the goal. Okay, and also as mentioned to you, right, later on I'll show you the SoC voltage, whereby I told you that not to run above 1.2. It's best to stay below 1.2, which I'll show you with another set of RAM. That will happen if you do not configure it properly. Okay, now after you have done all the markdown and I've explained to you what's actually going on, take note on the CPU power and the SoC, which this is not a bother because I've set it to 1.15. Just take note on the CPU power. Now I forgot to mention that you need to install Cinebench R23 to run the stress test. Now I'm just going to put this one side under here. Based on the configuration right now, I've not done anything except for enabling the Expo profile. As you can see here, curve optimizer I'm not done, curve shaper I'm not done, even the limits I'll just let it default. And next I will load the firmware and to run. Now why am I running this firmware? Based on the fact that this system that I'm testing, right, is without a discrete graphic card, and rest assured that with the settings I've done, right, which is on the moderate method, even if I have to plug the discrete graphic card, right, it will work. Just happened that this test is mainly on stressing the processor and such, so I'm using the discrete graphic card, or should I say discrete graphic that is built in to your processor to stress on both processing and the graphical content. So this is why I pull the firmware. So when I run the Cinebench, right, it will be together with the firmware. Next will be Aida 64 or Aida 64. Now I find this application is much more better in a way that it shows overlay stats as configured as compared to hardware info, as all these are necessary to show. And how do I actually get this overlay? On Aida 64, right, there's this button here, OSD. Okay, initially it's without. So when you press this, right, it will give you this. Then how do I show all these stats? You can do a right click, do a configuration, and this will pull all the sensor of your motherboard, and it will take some time, let it load. So once this is loaded, right, you can start selecting items that you want to show. Okay, see, this is listed. So for example, let's say I want to show the time. Okay, take a look at the overlay. So when I apply, right, see, it will list. So I already prepared all that I needed to show you over here, and I'll just go through briefly what they are. The clock speed. This is basically to show you the base clock or the boost clock of your processor during the Cinebench itself. Then the RAMs that I've actually done. This is a 48 gig kit as shown over here, right? See, use and the free. So when you total out, right, it's 48 gig kit. And this is the RAM timing itself when I enable the Expo profile, and it's running on the FSP ratio and such. And the BIOS is actually on this latest updated BIOS. Things that you need to take note are all the temperature, the CPU, the motherboard, the chipset, the VRM, which is actually the MOSFET MOS, and followed by, okay, this is redundant GPU. Okay, you can ignore this. The 2D, okay, probably I'll just, take off the GPU because I don't find that this is appropriate. Okay, let me just pull down. Okay, we say temperature. Okay, GPU. I'll take this off so that you have better concentration on the rest. Now, with all this say, right, later I'll take down the temperature after I've done the 10 minutes run. Then followed by my RAMs and my M.2 temperature. And this CPU, this is actually the radiator fans, how much it's actually pushing. And this voltage over here is for my reference, which is important. I need to know how much VCore is being put during the process on the Cinebench and the chipset and the SoC. Okay, now for under 64, right, the SoC voltage shown over here is more accurate as compared to the Ryzen. Okay, it's actually shown over here. So I will take this reading instead. So right now I'm just going to run 10 minutes and I will explain the result on the, explain the results as in like the temperature and such. So here we go. I'm just going to run this and oh, hang on. Before I run anything, one last thing that I forgot to mention is the hardware info. Now, this is to show you the base clock and the boost clock frequency of this processor during the Cinebench run. And this graph here is important just to show you that, in fact, this 9800 X3D, right, is fantastic. It's very consistent on this board. So how I get this graph over here, right, is by pulling the average core clock, double click on it, and this graph will show. Okay, of course I will position it. Say you can position it. So it just happened that everything is preset properly for me. I'm just going to reset this and going to run the 10 minutes, and I will talk about it before the I should say the last 3 minutes or 2 minutes. Here we go. Okay, this is the last 3 to 2 minutes. Is in fact the last 2 minutes 20 seconds. Now looking at the stats over here, right, I will take down all the readings, starting off with the CPU power. Taking a look, it is drawing 124 to 125 watt. So I just put this CPU power, okay, at 125 watt, which is the max. Then take a look at the clock speed, which is 5190 to 5200. I'll just do it max at 5190. Okay, this is the base clock, and the boost clock is 5225. Okay, boost clock is 5225. Now I'm just going to do this base, and this is boost. And when you look at the graph, right, as you can see, lots of jagged and even drop lines. This is, to me, not very stable because the system itself, right, is trying to pull and pull and pull and such, which is pulling to the max by default. And looking at the temperature, okay, the motherboard, I'll just take down the readings. Motherboard at 49 degrees Celsius. Then the CPU is at 79 degrees Celsius. Then for the rest, right, the chipset and such, okay, probably I'll just put it. And I will compose this to a spreadsheet later on. 44 degrees Celsius, the MOSFET, which is the VRM, also 44 degrees Celsius. Then followed by my 2 DIMM slot. DIMM 1 is 38. Okay, in fact, DIMM 1 and DIMM 2 are 38. Now, do note that my room temperature, right, is 30 to 31 degrees Celsius to have this reading, and it's on open bench to 31 degrees Celsius. Okay, then looking on the VCore, which is drawing 1.19 max. Okay, the SoC as in log 1.16. Now this SoC is the communication voltage between your RAMs and your processor, because your processor has this PMIC that, you know, calculates the RAM timing and such. which is on your RAM, which is known as the IMC. So right now it's 1.152. In fact, it's 1.16. I saw it max. Now looking at the score, this is 23011 points. Now let's do the configuration. Since I've taken down all this, and I'll take you to UEFI. So I'm just going to close all this. Did I miss out anything? Nope. Okay, that's good. Alright, I'm just going to close all this and to go into UEFI. Okay, here we go. And to show you what curve optimizer and curve shaper can do. And this will take some time to load. UEFI is loaded. So right now is to configure. So basically I will just do this. First thing, advanced setting. Okay, I know a lot will use this AMD overclocking for the precision boost overdrive, where you have this prompt here. The very first thing you need to check is on your SoC voltage. This is got to do with your Infinity Fabric voltage, which I mentioned to you, your processor and your RAMs. Make sure this is, wrong, this one, SoC uncalled OC mode. Make sure this is enabled. Okay, first thing to check. Now next is to do the precision boost overdrive. Now I will not do the precision boost overdrive configuration over here. I will explain to you why. Based on the fact, when you set this, right, there's only disable, enable, and advanced. So when you set this manual, right, all this are in millivoltage. So imagine that if you want to set, let's say the default setting right over here, 162 watt. Instead of keying 162, you have to key in 3 more zeros, as this is milliwatt. So I will just skip this totally, just leave it auto. Escape all the way out till you see this side menu. Go to overclocking, okay, and go to advanced CPU configuration. Now this will react on most MSI B850 boards or X870E boards. Okay, you can take this as a reference. Next, go to AMD overclocking. Then you can set the precision boost overdrive. From here, as you can see, there are different profiles. Now you can play with this profile, but for me, right, I would advise to have total control of what you're doing. Set this to advanced. Next, PBO limits. You can let it auto to run at this, okay, with the default, which is declared by MSI. But for me, right, I would like to have total control. Instead, I will set it to manual, and never to set it to motherboard. Okay, some of you have weakness on my previous content on the X870 Nova, right? If you set to motherboard, right, you are telling the system, I don't care about how much it's going to draw on the wattage or VCore. It will just push, it will just pump. So different UEFI SNI, different updated BIOS, right, will have different configuration. So I wouldn't do it SNI, having auto, okay, or to have it on motherboard mode SNI to set the PBO limits, because this is, you're letting the system to declare by itself, not on your own. I would rather do it in a way that I have full total control. I'll set it to manual. This is the way that I feel you should do. Or should I say, I prefer this way. So taking a readings over here, right, all this are the default settings. Oops, did I delete? Okay, here, which I've taken down earlier on when I show you. So plug these figures in. Okay, so I'm just going to do it right now. So this is, oh shucks, 162 watt, followed by, this is 120 watt, 120 ampere, sorry. Then followed by the EDC, which is 180 ampere. So double check on this, see, I got this in, which is correct. Next thing to do, a lot of you will do this based on YouTubers out there. I mean, I wouldn't encourage this. You will set this scaler to times 10. No, do not do this, okay? In fact, this is hurting your processor because it's pushing VCore 10 times more. Okay, this is what it meant. So I'll just set this to auto. I do not touch this at all. Next will be the CPU boost clock override. Now, personally, I do not like to use this at all, but a lot of you like to do that. I will show you what's the difference between using it and not using it. For now, just for the sake of it, as in like the fun of it, I'll just enable. Okay, set it to positive. Then you can run 200 if you like to, but for me, I'll just set it to 175 just for fun. Now, coming to curve optimizer and curve shaper, right? Whatever I'm setting right now, right? I'll explain to you in a graph. For curve optimizer, since this is a 8-core processor, not a 16-core with dual CCD, I'll set it to all-core, having a negative sign, and to set it at a magnitude of 20. Now, some of you might say that, hey, Cleo, you can set 50, not a problem. You can set 40, not a problem. If you have a very good bin processor. Now, let me just answer you this question. Imagine that your processor is an elastic band. Okay, by setting 50, right, you are stretching to the max. And this elastic band has been stretching 50 all throughout when you run your system. And in prolonged period of time, right, with this 50 tension, right, you run this about 8 months or maybe a year or so, right, the elasticity of the tension will degrade. So that will either, let your system unstable, or it will even snap, not to boot at all, okay, or to totally degrade your processor. I would not advise you to push that much. Do it moderately, whereby this setting allows everyone to set, which is -20. It's a very easy cushion kind of stretch. Now, if you have set this to -20 and you run Cinebench in Windows, right, and it crashes, right, do not panic. Come back over here, reduce by 5. Okay, if still can't, reduce by 10. Alright, but most of the time I've tested in different 9800 X3D, right, it works. Because due to the fact that most of these chips are done with B0 stepping, which you can run at -20, not an issue. Next will be curve shaper. Now for curve shaper, right, it's rather daunting to explain, but I'll explain you the full caption with a graph. At the moment, just take note that for each point, right, there are a total of 5 points where you have minimal frequency, low frequency, medium frequency, high frequency, and max frequency. And all this frequency, right, it has 3 points. Low temperature, as you can see over here, low temperature, mid temperature, and high temperature. Same goes to low frequency. Okay, don't get mixed up. Low frequency with low temperature, low frequency with mid temperature. Okay, all these are the 3 points. Now, I will not do any settings on the minimum frequency and the low frequency, where this is not the action take place. The action take place is only on the mid frequency. And whatever I've set down here, right, you are safe to use these settings as I've tested in most of the processor in different boards and such. Okay, it will work. So just enable it. This curve shaper is just like curve optimizer. You are just doing a fine tune of pulling with a negative magnitude. So when you enable, right, just make sure that you set it to negative. Okay, and always double check what you have done. For the settings I've done, right, since there are 3 points, right, all these 3 points, I mean the temperature points on each frequency, right, starting with medium frequency, I'll set it to 15. Okay, as mentioned, you can make use of these configurations. Alright, just go slow, you don't have to go fast. Just make sure that you've done correctly. See, I've done the first set with medium frequency, with the low temperature, medium temperature, and the high temperature with all 15. See? Next, we'll be setting on the high frequency. Same thing. Do the exact same step, but on the magnitude itself, right, set it to 10. Okay. And make sure you double check. See, if I don't double check, right, I might just set this to positive, which can be disastrous when you run your Cinebench. It might just crash. So come to the max frequency, the last part, same thing, do it gradually. Make sure you know what you're doing. Or should I say, be more attentive of these settings because it's fine tuning. Now I've done everything, so double check the max frequency with all the 3 temperature as 5. Okay, that's done. Then the high frequency, okay, negative 10 10 10. Okay, that's good. Then followed by the medium frequency, which I've started with this point, all 15. Okay, great. Now what does this curve shaper do? Now just an illustration. Looking at this graph right now, do not take this as the actual graph that what I've done on the settings. Is just an illustration. Okay, if you're not doing any curve optimizer and curve shaper, running the system at default, this is the default current line. Okay, having to put curve optimizer as -20, you're pulling, or should I say you're pulling the current lower. Imagine this is actually running at, I would say, around 200 watt or so, right? Or at that amperage. When you do your curve optimizer, right, it's going to draw down. Instead of pulling to the 200 watt, it's actually pulling lower, much lower. Can be around 160 and such. Okay, just an illustration. As for curve shaper, right, as you can see, you have mid, low, medium, high, and max. In fact, this whole curve, right, is exactly the same as the curve optimizer. Instead of pulling a straight line down from the default current, it do fine tune. See all these points where you say -15, -10, -5. So it's a graduate point. So it's not so steep. So when it reaches to the high clock speed, right, instead of drawing 15, right, you're drawing -5. So this is actually what it meant. Now I'm just going to save this setup. But one thing before I do the setup, as I emphasize on this, I do not like to set this max CPU boost clock override. Okay, reason for this, let me just show you. Just going to save and reboot, and this will take some time, as the system itself, right, will try to do its RAM training timing again and such. So this will take some time. See, it's booted. Then again, when it boot to Windows, right, at the initial stage, it will take some time because it's recognizing all the configuration off from your UEFI and to plug to the scheduler on Windows itself. So once it's done, right, when you load, let me just show you what's going on. Emphasize again on the CPU boost, which I've done. Okay, again, this is actually not a 16-core processor. That's why the loading on the background application, right, will take slightly longer. I just want to make sure that everything runs smoothly before I pull the Ryzen Master. Okay, this is done. Let it sit for a while. Okay, see the hourglass, the turning is still turning circular. Alright, right now I'm just going to load and to show you configuration that I've done. PBT all manual, as I want full control of what I've set to the system and to declare what to pull. Next, the boost override CPU. Okay, this is the one that I dislike a lot. Coming to the curve optimizer, all core -20. Now it's a shame that Ryzen Master doesn't show the curve shaper, but I already installed in as your weakness. So right now I'm just going to run, and I'll show you what's actually going on. Okay, let me just put this here. I will load the stats on Aida 64. Okay, this will show the stats. Yep. I'll put this over here and to expand the whole CV bench. Next will be firmark. Okay, I'll run firmark. Then last but not least, hardware info. As you can see here, right, the graph here. Now, as I mentioned earlier on, default, okay, your weakness to benchmark. The curve here is not straight, it's jagged lines. So see what happened when this is run with all the settings that I've done. Okay, oh, by the way, for your info, I've done up a stat Excel spreadsheet Okay, and what are this? This is actually the default where I return over here. So this is hard to compare, so I'll use this as a comparison. So I've done transferring all the stats over here to here. Now, I'm not going to run this a full 10 minutes run. Based on the fact, I just want to show you the boost override CPU, okay, that I've set to 175, or you guys have set to 200. Take a look at what happened just for a few minutes, okay? I'll let it run. Probably you might get shocked. Wow, that's a good result. See, I'm having a base clock of 5.3 gigahertz, and the boost is at 5.4. Well, clear, this is the way to go. Look at the temperature. Yeah, previously by default is 79 degrees Celsius, and this is 77 degrees Celsius. Now, if it's going to run a full 10 minutes run, right, probably this will be around 79 degrees Celsius, or maybe 80 degrees Celsius. Okay, and all this will increase, that's for sure. The temperature on the motherboard, the chipset and such, it will definitely increase. Now, come to the point. Yes, it's very good result with all this, and it's sustainable. And look at the line on the core clock is flat. This tells me that the system is stable. True enough, it's stable. But one thing I do not like, take a look. How much is it drawing on the CPU power? It's drawing 123, 125. It's just like the default. So this is just like as well, you have not done any undervolting at all. So that's the reason why I do not like this. And looking at the fact that yes, it indeed it's 5.3. Okay, take a look at the. Okay, this is 5.3 base clock, which is above this by about 100 and something megahertz. Is it worth to run this base clock with this power? Some of you might say that, hey, it's almost the same as the it's better in fact compared to the default, which is 125, okay, which is down here. True enough, and it's running 5.3 gig base clock and 5.4 at max boost. Temperature is about the same. Okay, as you can see here, it is 79. Now, as mentioned to you, this is not a full run. If this is, see, this is going for 79. It might have the same temperature. You might want to run this, right? But for me, I'm not satisfied with it. Let me just show you what happened if I were to remove this off. Okay, I'll just close this. Now I'm just going to shut down and go to UEFI. Go take a while again to boot up to UEFI. Alright, just to wait. Now, if you guys are comfortable with this kind of settings, right, you can go ahead. But for me, right, I'm not happy with the current drawn, as I always like to do it with lower wattage but yet able to perform. So to me, right, that 100 over megahertz, right, to me is nothing. Okay, I'm so sorry to say this, but this is me. So let me just put this, okay, to disable. Nothing. Alright, I minus off the 175. Take a look what happened right now. Okay, it's going to load to Windows. Just need it to restart, do the RAM training timing again and such, getting use of the new settings I've done on UEFI and to boot into Windows. Again in Windows, okay, I think I repeat this myself again and again. Do not panic, as in like let it run. Because once you have done all these settings, right, once you start to use the system, right, this boot time will not be that long. Okay, so take note on this. Alright, booted up. Now, I'm just going to run 10 minutes throttle test on this, okay, and to show you the final result. And what's the difference between removing the CPU boost configuration, and as I showed you right earlier on, is with the CPU boost configuration at 175 megahertz. So right now I've disabled that. take a look at what happened. True enough, I can tell you up front, yes, there is a performance drop, but the performance is only about 150, 175 megahertz. But you're drawing that current with that CPU boost configuration. See, I've not done any boost configuration, leaving the rest of the settings. This is as usual. So right now I'm just going to pull this in as in like to run the Cinebench. Okay, let me just expand this. So at the meantime, I'm loading the stats and also firm up. Okay, let me just align this properly first. Alright, firm up. Now I'm just going to run a 10 minutes test and to show you and what's the result by the end. Okay, and here, okay, let me just reset this. I reset this. Okay, why am I resetting this, right? Just to show you that how much it can perform as in like the base clock and the boost clock. So let me just reset this again and I'm just going to run. Here we go. Alright, the last 3 minutes. First of all, let me just take down the readings before this go off. I'll start off with the power consumption, as in like the CPU power, the core power is drawing 107 max. Okay, then for the base clock and the max boost over here, as you can witness, is consistent. By the way, this is consistent. Take a look at the graph. It's a flat line. This is something which I like to see. It's very stable. So it's not trying to struggle or to pull. So as this is actually 5.225 gigahertz. Okay. Same goes to the boost clock. It remains the same. See, I don't have to worry. I don't have to wonder, oh, it's going to push at random timing. All the while it's consistent, as you can see over here. Now, as for the rest of the temperature, I will just take it. Okay, let's do this. The motherboard temperature 0.9, CPU temperature 71, chipset is 43, MOSFET is 43. Okay, that's right. The 2 DIMM slot are 38. No change, which is good. And the M.2 41 degrees Celsius, no change. Now look at the voltage. VCore 1.118. Okay, and the SoC is 1.6. It's the same as I locked down. Now, just to wait for the scores. Now, as I mentioned to you, right, previously when I run with the CPU boost at 175 megahertz, the voltage, is within that few minutes, not even running throughout the whole run. It's running at 250 or 223 and 224 watt. Okay, as compared to this without that, I'm running at 107, which dropped about 15 or so wattage, which is a good sign. And furthermore, the temperature, right, it drops drastically as compared to the CPU boost, which is 879, which is about the same. So imagine that. And yes, true enough that the boost clock is 5.3 using the CPU boost, and the max boost is 5.4. But just that few megahertz, would you prefer to run at a lower temperature and a lower wattage, drawing a lower wattage, and to prolong the life of your CPU? For me, I would choose this route rather than to push it to the max. So this is the reason why I say that I do not like to set the CPU boost. And with that, right, there might be times whereby the system is actually trying to push and push and pull. I mean, trying to pull. So that is actually a figure for it to pull. You have redone the curve optimizer and the curve shaper, which is drastically, pulling lower current, and yet you still want to push the frequency. So there is a snap over there, you see. So that's why I wouldn't want to do that. Now, with this say, right, the final result is 23,126. This is where the point you will have to take note on when you're using high bus speed RAMs. And both of this, right, in fact, the first run that you seen on the content itself is making use of this CL28 48GB kit that's running on bus speed 6000. I removed this off. I will plug this in later, and to show you, these are the similar capacity, which is 48GB kit, and it's on running cache latency of CL32, but the bus speed on 6800. So do take note on how much SoC voltage that is drawing, and this is the critical part whereby some of you are not aware, and if you keep on running at this speed with the SoC voltage, right, it will damage your processor. I have swapped out the RAM kit where previously I'm using a 6000 bus speed. Right now I'm using a 6800, and of course I need to clear CMOS everything before I can plug in the new RAMs and to let the system recognize it. And again, rest assured, all the settings like the overclocking profile on the precision boost overdrive, right, I already port back all the settings the way that they are, like how I show you on the previous one. Now coming to the RAM profile, okay, now this RAMs you can cater for XMP or Expo, but I'm going to enable Expo, which is looking at the profile, right, 6800. Maybe I should show you this, then you will understand what is actually going on. And on top of which, right, okay, I'm not going to set the Expo profile. I'm just going to run as it is on Cinebench. And in the meantime, okay, under here, which it says CPU MB SoC voltage. Previously, I've set to 1.15, but right now I just set it to auto. I let it run it this way. So I'm just going to save it, boot to Windows, and to run Cinebench, and to show you that something that you will have to take note when you're doing this. So it's going to take some time to do the RAM training and such before you load into Windows. Okay, right now it's actually loading into Windows. Again, I'm not going to repeat myself. This will take some time. As I mentioned to you, Windows will take in instruction from UEFI before it loads. Okay, Windows loaded. I'm going to let it run the Cinebench. So let me just toggle Cinebench first. Okay, increase this size over here. Gonna load Ryzen Master. Oops. Okay, sometimes it does this, but not to worry, you can run again. Hopefully it will load. Okay, see, it loaded. Now the SoC, as I told you, right, I've not set anything to it. I let it auto. So right now it's actually 1.0 volt, which is okay to run, safe to run. And as mentioned to you, the rest of the settings, right, is as usual. I'm not touched. Now just take a look on how it runs, just to show you that these are the 6800 gig RAMs. Sorry, 6800 bus speed RAM, which is C over here. Oh, sorry, which is C. This is the default. Okay, no Expo profile running, and I can run not an issue together with firmware. The SoC voltage will not increase, which is okay. This is safe to run. See? So if I were to run this, right, see? It's just like usual. It's drawing around this voltage, and the SoC voltage is not 1.2 and above. It's under it. based on the fact that I have not enabled XMP profile. Take note on the memory training timing. Okay, by right it should be running on CL32 cache latency with the Expo profile, but right now it's not. It's running by default. So right now I'm just going to stop everything and to configure it and to show you what is the SoC voltage. Let me just close all this. I know this is going to take some time, so bear with me. This is very important for those of you using high bus speed RAM. I'm just going to boot to UEFI. Okay, it's booting up. Now, see what happened when I trigger Expo profile, which right now I'm just going to do it. Oops. Right. And having to say this, right, for this Expo profile, I know that with such high bus speed and such loose timing, right, I am not able to set this high efficiency mode to set this memory timing preset to tightest. Okay, it will definitely crash. So that's why I say that it depends on what kind of RAM modules that you're having. If you're using 6000 with tight timings, right, you can try to use this high efficiency mode. Now, without further ado, I've actually enabled the Expo profile, which you can see over here, going to run at cache latency 32 at a bus speed of 6800. Now, and also to the fact that, as a reminder, I've not set this. This is on auto. See what happened. I'm just going to save this and to boot into Windows. Here we go. Okay, booting into Windows is pretty fast to pick up. Just one profile. Now this is normal, whereby, you know, Windows is going to, I mean, it's going to pick up the creation. And with this said, right, I'm just going to let you see what are the things that have been done and changed. Again, a reminder, I've not set the SoC voltage to 1.15. This is on auto. And many of you are not aware, running high bus speed RAMs, right? Take a look at the SoC voltage. Okay, I'm not going to run any Cinebench on this because to me it's rather scary. Okay, let me just load Ryzen Master. Hopefully you will pick up. Okay, great. Take a look. The SoC voltage is 1.3. It's already above 1.2. So unknowingly, let's say you configure like what other YouTubers have been telling you, right? You know, set to motherboard and such, and you just run Expo profile without noticing this, and your RAMs is running at 1.3. Okay, anything above 6400 bus speed, I will not run this on Cinebench because I know that this is above 1.2 and it's definitely going to hurt your processor. Just to show you the stats on Aida, take a look. 1.3 throughout, you're killing the processor. So do not run this at all. If you are running a high speed bus frequency, right, on the RAMs, right, kindly take note on the SoC. Okay, make sure it doesn't run on 1.2 and above. So with this said, right, I'm going back to BIOS. Alright, you're going to take some time. I'm going to load in no time. Alright, back to BIOS. Hopefully you'll be soon. So right now you're seeing, if you only enable Expo profile, you're not aware that, you know, the SoC voltage is 1.3. And if you run your system throughout, right, in no time, you know, you're going to degrade your processor and you will just die in no time. So the best way to do it, I would advise, is to set. Okay, if you are running a high bus speed, which I don't find, you know, it's necessary to buy a high bus speed, which doesn't really benefit that much. The best sweet spot is 6000 to 6400 and with tight timing. So with this say, right, take a look at the SoC, which is under auto. See, 1.3 volt. So you need to bring this down. And I would to suggest override mode. Okay, and set it to 1.15. save the profile and run Cinebench, and to run some games, or even do OCCT tests and such. If it crashes, right, come back here, pump it to 1.8. If you can't, max go 1.2. If you can't, sell off your RAM, get a low bus speed. Right, I know that these RAMs are able to run at 115. So let me just save this, and to show you. In fact, having a high bus speed RAM, right, it's kind of like, to me, it's kind of like dangerous, because you need to be aware of the wattage is being put from the system itself. Even though I've set to 1.15, right, sometimes it will jump to 1.16 or 1.17, or even after 1.2. That's the scariest part about having a high bus speed RAM, which, as mentioned, right, it doesn't really benefit much, as the RAMs are much more expensive. But when you start to use it, right, the performance is only very little. Okay, gonna let it load. It's gonna take some time. Alright, hopefully it's loaded. Okay, right now I'm just gonna load Cinebench as usual. Gonna do a run and to show you. Okay, I will run Ryzen Master. Okay, take a look. The SoC right now is set to my settings, which is 1.15. Again, gonna trigger the stats. As I mentioned to you, right, Aida 64, the overlay, right, this SoC is more accurate. See, this is 1.52 and this is still 1.15, which is my settings. So right now I'm just gonna run Cinebench, okay, just for a side while, just to show you. I'm not going to do a full run. Okay, which is this. Okay, we're going to load the firmware. Alright, everything is done, so I'm just going to load or run. Okay, as it's run, I just pull this out. Everything will be the same as usual, nothing much to worry about on the PBO2 and the curve optimizer or the curve shaper. Take a look at the SoC. On Ryzen Master is 1.150. On Aida 64, right, see, 1.158. So I should say that so long as this is not running 1.2 volt and above, it's still below 1.2, right, it will be okay. So do be mindful when you're running a high bus speed RAM. Make sure to take note on this. If not, if you're running 1.3 volt, right, you will definitely burn your processor. Hope you guys have enjoyed what I shared with you, and I've learned a great ordeal fiddling with this 9800X3D. As my main objective of this content is to make awareness to everyone, and often read on Reddit that the processor went dead, the motherboard went dead and such, based on the fact that monkey see, monkey do. Everyone just view on YouTube, and there are tons of YouTubers stated that, oh, to follow these settings and such, but they are not aware of how much voltage is being drawn. So with this illustration, right, telling you that these are the configuration that you need to take note of. And I know there are lots of gurus out there might come to my content and to comment, oh, you can set this, you can set that. It's a no-no situation when you want to configure something, because you have purchased a very expensive processor and a motherboard, and just a slight difference in current, right, you can ruin your experience by not having the board working or the processor working. As I read on Reddit, right, some were saying after a few months later the processor went dead, if not the motherboard went dead. So these are the minor things that you need to be aware of when you're doing PBO limits. Make sure you have full control of it, as in like follow AMD settings and not following auto configuration or motherboard configuration, based on the fact that different AIB boards, right, they have their own set of configuration. So do you trust them or do you trust yourself? That's the question. And when you're doing the curve optimizer and the curve shaper, as mentioned to you, I set it in a moderate way, whereby I do not stretch. Take for example an elastic band. If you are to stretch it to the max, let's say around this much, For prolonged time or period, right, the tension on the elastic band will deteriorate. This will cause your processor to go unstable, or it will just snap, which causes your processor to go dead, or even your motherboard. So make sure you do it in a moderate way. And also to take note, when you are doing all this, right, take note on the CPU power on Ryzen Master. Okay, make sure that go according to the specification of what AMD have mentioned. There is a reason why they have placed the specification on their website. So it's just that the carelessness of end users, right? They just want to stretch to the max. They just pull all the way to the wattage, which is above 120 watt. They can pull maybe 200 watt and such. Now, YouTubers out there, they are provided with this processor on loan or such. They can show you what's the max performance during that period of time. But what if you to run it in the long run? Having the processor running above the specs, which is more than 120 watt, and to stretch all the max, as I mentioned to you on the curve optimizer and curve shaper, right, you will definitely kill the processor, that's for sure. So do be mindful. You spend so much on it, make sure that you take good care of it so that it will serve you in the long run. Also, another factor, which are the RAMs I've shown you. Okay, most of the time I've been using the bus speed of 6000 megahertz or 6400. In fact, most of the time it's 6000 megahertz, and I choose tighter timing, which is CL28 instead of CL32. This will help the performance. And also, if you were to plug any RAM stick that is above 6400 and running, at this kind of bus speed, right, the higher you go, it will draw more SoC voltage. And as you see, right, if you have to set it auto, yeah, blindly everyone will do that. Follow YouTubers saying that, oh, you just enable XMP profile, don't have to worry about SoC and such. Okay, they don't touch on that. And furthermore, you're stretching everything. Curve optimizer, curve optimizer, make it to -30, -40. The snapping factor. Another thing is the RAMs. The higher RAM bus speed it is, the more SoC you're gonna pull. You weakness yourself. There is warning signal on Reddit itself saying that please do not run SoC above 1.2. Even I check out with the AMD personnel, right? Now, why is it so that you should not run more than 1.2 volt? The communication between the processor and the RAMs, right? There is a chip where this is the IMC, where else here is the PMIC, if I'm not wrong. They communicate with each other, and on your power face on the motherboard itself, right, where you have 12 plus 2 plus 1, 12 is in fact the processor, 2 is in fact the SoC of your processor and the communication to your RAMs. So that is the voltage that you need to take note of. If you run 1.3, right, it is not the PBO2 and the curve optimizer that is killing your processor. In fact, it's the RAMs that's drawing that much that will kill your processor. So do practice, safe practice. Now with this said, it's honor to share with you all these findings and to check out with AMD, especially to AMD Singapore. They've done a very wonderful job to explain to me on certain things that I do not understand. Right now I fully understood. Thanks for supplying the sample on the 9800 X3D, and to King Bang to have supplied the RAMs. Without all this, I am not able to illustrate what is actually going on. So with this said, right, I hope that everyone here, once you have watched my content, please practice safe settings and be mindful on the wattage and volts. Wattage on the current drawn on the processor, make sure there is a limitation on it. There is always a reason why AMD have stated the wattage TDP as 120. It's just that there are heroes out there. I mean, showing the benchmark and such, they will just pull and pull and pull. Are they going to use the processor for long? They are just showing, showcase. For yourself, you're using it for long. So make sure you have a stable, foundation on your settings, and make sure you're aware of what you're doing. Now with this said, thank you everyone for watching, and if you are new to my channel, welcome to my channel. If you like my content, do remember to subscribe and not forgetting to click on the like button if you like this content. Till the next time, take care, goodbye, see ya.